What's up, Shifter? Chopsticks. Dun, dun. One sec. Okay, we're gonna stop the music. There we go. What's up, guys? It's Wednesday. Love good Wednesday. Almost the end of July, actually. Yeah, is this the last Wednesday in July? I think. What's up, Juju? You have fun playing Fortnite with us last time? Some pretty hard lobbies. Yeah, next Wednesday is August 2nd. Wow. And this year has been just going. I guess it's sometimes a good thing. What's up, Yachty? A resident artist in the house, Yachty. Okay, Juju. You didn't die as much as Noise did. Kept taking fall damage. What's up, Yachty? How's the art been going? We have a whole here, oh, there we go. Yeah, I found it. Okay. Yeah, we have an art. Which some people have like, it's cool. Like students like submit their art. Like this is some pretty dope pixel art that I guess the Lizard did. I think some website called, was it Hiskel? Okay. Reminds me of like back in Microsoft Word, they used to like make art. Jamarcus did some painting. That's sick. I kind of like this one actually. This looks like the Earth is floating in a awesome energy. That's cool. Spray paint. Yachty is, yeah, look at this. Like, what? Ooh, Teacup's here. Teacup is joining the stream from Disneyland, dude.
That's dope.
That's some dedication right there. Like, if you're gonna join the stream from Disneyland, like, what? Have you been on any rides yet, Teacup? It must be pretty late there, right? Yeah, it's like 7 o'clock, I guess. Time. I know the park technically goes up to like 2. Yeah, that's cool. My favorite ride is the Winnie the Pooh ride. Literally, it's the most underrated ride, but it's actually the best ride. And there's no line for it. And it's, what is it? Winnie the Pooh ride. Wait, what is this? Winnie the Pooh Blood and Honey? Excuse me, what is this? Why? What? What? Noise, do you see this? There's a British independent slasher film called what? Winnie the Pooh Blood and Honey? This is scary as fuck. What?
Yeah, it's a bit weird.
What? Have you seen advertisements for this?
I think so, yeah.
Budget less than $100,000. Grossed $5.2 million at the box office. Wow, that's dope.
That's dope.
That's what? That's a 50-time return on your investment. That's not bad. Okay. This. I think I might have to watch this film, honestly. I don't know. I mean, like, let's see. Is there a trailer for it or something? Man. But yeah, it's the Winnie the Pooh. Not the Winnie the Pooh Blood and Honey. Yeah, this is someone's actually. I love this when someone like takes a camera and like literally watches, records the whole thing. Also, I feel like YouTube's been getting really aggressive with their ads. Like, I don't know, I see a lot more ads on YouTube videos now. Here, let's.
And why am I so special?
Because soon we'll be Christopher and Mary Robin.
Oh, Christopher Robin gets married?
We're not going to find them.
We will. Pooh, Piglet,
Uh-oh.
Eeyore,
Uh-oh.
we were friends for many
This
years,
isn't-
and they're out there.
Not gonna be good. Oh, it's not gonna be good.
Christopher, we need to leave. Now.
I really need to find out.
Oh my god. What? It's like Five Nights at Freddy, but like. Oh god. Oh god, this is scary.
Friends, why are you doing this, please?
I usually don't like slasher films or whatnot, but I think maybe this is probably a good one. Oh god. Okay. Honey. All right. Okay, cool. Anyways, let's take off the stream. All right. Welcome everyone to Office Hours. My name is Dr. Willis, Actual Education. Stream that helps you out with math homework, science homework, all that fun stuff. Some good news. I heard back from the brilliant people, and they talked to their department and gave me the ability to give out up to 30 accounts to you guys, which is super cool. So I'll make an announcement in the server later about that if you guys want access. Send me a DM and we'll make like a separate challenge. Should be pretty fun. They also may sponsor a prize. They said maybe up to $1,000, which would be really, because that's usually what my like lowest cost it is to run like one of these like summer camps or one of these events is about $1,000. So yeah, if they give me $1,000, yeah, I'll run. Maybe we'll run like a fall MT tournament, and y'all think about like what, maybe we'll do like a $700 prize and a $300 prize. So you think about like what prizes you guys want. Maybe a gaming laptop or a Steam Deck, and then I don't know, something else. Ethan says, "Give me one." Yes, Ethan. I was thinking about you when they said that they had accounts, and I think this would be very useful for you because it would help you learn more about physics and math and stuff on your own schedule and your own pace and whatnot, and then that way we can help you out. Or Noise has been helping you out a lot, which is awesome. He can help you out with like different courses you're going through. But yeah, I'll make an announcement. You're one of the first people I thought of, as well as like Jamarcus, and we have a lot of other people in our Discord, which I'm really proud. You guys are just like learning on your own. That's really cool. So yeah, I'll get you guys those accounts. All right. Let's see. What do we have for questions today? Lexi had a question. So here, I'm gonna put this one in real quick. And then Lexi just joined our Discord actually. Curious if they're on, or if not, I'm gonna at least show them the recording for this. Why can I not copy image? Want to paste? There we go. That one wants to paste. Okay, that's Noise's question. One sec. Oh, because this image is massive. Okay. Let me... There we go. Yeah, I think it's awesome with the student accounts. So I saw that, like, for instance, I can create here. I'll show you guys. Like, I can create my own like classroom and whatnot with courses that you guys can go through. But then apparently, once you have an account, you also have access to all of these other. So I myself, I can create a classroom and add students to it so that I can see how you guys are doing in like specific classes. And maybe this will be an idea for the tournament. I'll like assign a class like a week, and if you complete it in the week, you get a certain number of points and whatnot. And this is cool because then I can auto see like how well you're doing. I don't have to hand grade it. In the past, I used to have to like hand grade things. Anyways, yes, copy this. Then we'll do Noise's tree problem. Need the tree. All right, says, what is the domain of the graph below? Okay, this is a cool one. So a good thing to know first is like, what the hell is a domain, right? Ethan or Juju, do you guys know what a domain is? I know Noise knows what a domain is. That's a pretty
See, I
basic.
actually haven't done that, so I've just guessed this.
Oh, really? You don't know this one? Okay.
I mean,
These
I
are so
think I
you
it.
know so much advanced math, Noise, and then they're like these little things that you like haven't seen. What did you guess, by the way? Let me know what you guessed.
See, because it's just like the range of x coordinates. I guess.
Yes, exactly. Yeah. So it's interesting that you said range because range usually
Yeah, 'cause range is y in it.
is just the y. It's like what we call like the y space. Oh my god, y space. All this where the domain. This is what we call like the x space.
Okay.
So yeah, if these are coordinate points, right? Let's say this is like x1, y1. This is x2, y2, and so forth, right? The x points we see are A, B, C, D, E. So yes, that's what that answer is. That's good. That's all the x points that are contained in these. This is like a set of points, I guess. That's what the bracket means around the print. Each one of these things in the parentheses. But then if I wanted the range, right? Let's look at what the range would be. The range would be all the y values. So I have a P, I have a Q, I have a P, I have an R, and I have a Q. Okay. So a couple of these are duplicated, right? This one and this one. So I don't really need to count it twice. So I can get rid of this one. So yeah, just P, Q, and R. Those are like the different unique y values you have with these points. So this is what we would say. This is what we would call the range. Call this the range. This is... Yeah. Have you done domain and range from like graphs before, Noise? Have you done that?
No.
You have, or yes or no?
I
Oh, you haven't?
No.
Oh, okay. Well, here's kind of a
No.
cool question. Let's make it a little graph. I'm gonna teach you something. I like teaching. Let's say we have a graph of, I don't know, let's say it looks something, some points. To make some asymptotes. You know what asymptotes?
Yeah.
Yeah.
It's like that time joke yesterday, wasn't it?
Yes. Yeah.
Can I invite Jamegas to speak? He's wanting to.
Yeah. Tell him he can come speak. I think we were playing Fortnite with him yesterday, weren't we?
Yeah,
Yeah.
we were. Yeah, you guys were.
What's up, Hamega, dude? What's going on, dog?
Used the same headset I had before.
Okay.
It was used. Got it, and it's coming in about an hour.
Oh, nice, dude. Where'd you get it from? Amazon?
Yeah, and pretty much there was like a
They had like an open box deal or something.
not really an open box deal, but more so like a what's it called?
Amazon warehouse.
Oh, no, wait. I had it. I got it with the I don't know what it's called. Like if it breaks, you can get another one.
If it breaks, you mean with the warranty?
Oh yeah, I meant a warranty. But
You
yeah,
just
I
like
got
told
like
Amazon it
the-
broke and they just sent you a new one?
No, I had to send it back, and it's coming in about an hour.
Oh, okay.
So that
Oh, you
the
did a
original
return.
thing, yeah.
There's also a strategy. This is called like the Amazon return policy, which is, you know, kind of against their terms of service as long as you don't do it too many times. But anytime something breaks, you just buy it on Amazon again and then just return the broken one. You know, not advocating for it, but yeah, I know a ton of people.
I'll just mute because you're doing this.
You're good, dude. You're good. Okay. All right, so here's a function here, Noise. I don't know how I would actually draw this function. It'd probably be kind of weird to draw. I mean, I don't know what the actual value of this function would be. But let's say, for instance, they give a graph like this and they ask you to figure out, like, what's the domain? What do you think you'd say for this function, the domain of the
Well, I know it's the like X space, but
It's
there's
all
a
the X
really
space, yeah.
stupid asymptote in it, isn't there?
Yeah, right? Yeah. So what
got
you
a
always
quick
want to do is you're trying to figure out what X values does this function here like reach. So usually we go from like
Makes
the
sense.
left all the way to the right.
Minus infinity to like
Good. Minus
slightly
infinity.
less than 3.
Right. So so this is an asymptote, so it gets infinitely close to 3, but it doesn't actually touch 3, right?
Yeah.
So this is how we would describe these values of X. We would put a parentheses here, we put a 3 here, and we'd also put a... This is what means it doesn't touch it, right? If it did touch 3, like if it wasn't an asymptote, then you would put a bracket.
Oh, okay.
Have you seen that before? For instance, if I want to say like, let's say this. Let's say X is less than 4, but greater than or equal to 1. The way to express this in what we call like interval notation would be this: 1, 4, and then they put a parentheses. So the bracket signifies equal to, and then the parentheses signifies doesn't equal.
Right.
But the key thing in math is that you can't ever actually touch infinity. So that's why we don't put a bracket here. Some people think to put a bracket there. They're like, oh, it touches negative infinity. But it's like, no, negative infinity isn't real. We don't.
What
Okay.
the hell was that?
I kind of like that noise, right? What's this? Where's this one? No. There you go. No. All I have is a MIDI keyboard, by the way, like doing this. So I have to sometimes remember like which sound is like C sharp, for instance. Which one is A flat?
I have a question.
What's up, Omega?
Is there like a free version of this app that you're using?
What app? The drawing app?
The one, yeah.
No. But I can give you guys access to one of my rooms if you guys want to just.
Is it okay if you can?
Yeah, no, I can. Yeah, I can do that.
Thank you.
There's a nice tool called Microsoft Whiteboard, which is free.
Is it free? All right, let's
I
check
think
that
so.
real quick. Microsoft Whiteboard. Okay. Let's just start it. Let's see. Starting the
Oh, you maybe need a Microsoft account.
yeah, it's okay. Okay. Works. Oh man, they have all these templates. Wow, look at all this synergy. Do this. Synergy. Cause and effect that. Oh, this is too funny. Okay, well let's say I don't want any. Can I just like draw things on it? Oh,
Yeah.
that's cool. I'd be curious to know what the hotkeys are and whatnot for this. This is actually pretty, yeah. Okay. And can you have other people join this?
I'm not sure.
Yeah. Okay.
I don't know.
So there you go, Omega. Yeah, Microsoft Whiteboard is apparently pretty cool. I think it's a lot more friendly, honestly, because like they have pictures for you can draw the shapes and stuff. That's pretty cool. I use this thing which is called Group World. This has been around since I first started online teaching back in like. But okay, yeah. So the domain here, yeah, noise, right? This is from negative infinity to 3. Okay, but what other x values does it touch?
Well, and then it's what that? It's the 3 again
Good. 3 again.
with the curly bracket and then infinity.
Good. Yeah, nice. And then what we do to say it's this and this is like they'll do this in math. They'll put a U here, which means union.
Oh yeah.
Yeah. You know this from probably computer science. This means like or, right?
Yeah.
Or and?
Yeah.
Or I forget which one.
And
Yeah.
is union, I think.
Oh, and is union. Right,
Is
yeah.
it? Yeah.
Union means it's this and this. Exactly. Okay, very cool. And then, right, if we wanted to get the range, which would be the y values, what would that be?
Well, it'd be what's that? Or minus infinity to
Good.
whatever that. What's that? -3.
-3. Good. Right, parentheses, yeah.
And then 3 to infinity.
Good. 2 to infinity is, I think, what this would be.
Oh, 2. Right.
I didn't draw it exactly right. You're good. Yeah. So then union, yes, 2 to infinity. Yeah, very good. Cool. Yeah. All right, there you go. You understand how to do domains and graphs, domain and ranges from graphs.
Thank you.
What's actually kind of a fun thing that they'll do as a math question is they'll give you the domain, the range, the asymptotes, and then they'll ask you to draw a graph that matches that.
Okay.
Yeah, it gets kind of. I can maybe show one of those. But yeah, let's. Okay. Actually, let me see if I can find one for questions. 'Cause I think we have some time. Okay. What is it? I probably have it on Chegg.
What's Chegg?
So, Chegg is a website that people use all the time to look up homework questions, basically. And
Okay.
they call it study homework help. That's a cute answer for like people just use it to just copy the answer. But I use it a lot of times because it has basically like free textbook questions because people post pictures of their textbook questions and then people answer them. But then I use it because I'm like, oh, if this is a question then that someone's asking about, then I can ask. No, Gabe, you're good. We're streaming. You're good. Chegg. Let's see. Draw a graph with given characteristics. Here we go. Oh, this is involving derivatives.
I'll look as well. I'll have a race to see who can find one first.
Yeah, they do it with derivatives too. That's always the other good one. Actually, maybe let me. Actually, really. There we go. Someone's like done. Problem's been solved. Wow, this is actually interesting. Full prime. They have a set. Oh, okay. Dun, dun, dun. Boop, 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 boop. Yep, Gabriel, here, I got you up. Here, I invited you to speaker, and am I late? No. Okay. All right, Noise, you've done a little bit with derivatives, right?
Tiny bit, yeah.
Okay. All right. So here's a nice little one they do sometimes where they say like sketch the graph of the function having the following characteristics. So let's see how you would do one of these. Pretty cool. These tend to mess up kids a lot. Okay, so they say f of 0 is equal to 4 and f of 6 is equal to... What does that mean?
There's roots at 4 and 6. Oh wait, shit, no.
Not roots.
At 4, y equals 0.
Good. Well, at y equals 4, x equals 0. What this means is...
Oh yeah.
Yeah, it's okay. It's the late night
Got that
smooth
wrong
brain.
around.
The late night smooth brain. Here, there you go, Gabriel. What's up, dude? Oh wait, he was up. Okay, well now not up again. Yeah. This was your whole joke, wasn't it? The f of x. At your wedding, I want the f of x to equal 0. Yeah. So yeah, this is the coordinate 0, 4. That's what this means. So
Yeah.
we know there's a point here, and we know at x equals 6, y is equal to 0. Great. Okay. Now here's the next little bit of information. They say that the derivative, right, f prime, is less than 0 if x is less than 2 or greater than 4. Okay. Kind of an odd one. Okay, so what does this tell me that the derivative is less?
I've forgotten.
So this means that it must be sloping down, right? If the derivative is negative, right, it means it slopes down. Okay. And I'm saying it has to be downward sloping if x is less than 2. Okay. So I know that it's probably something like this if it's less than 2. And if it's greater than 4. So it's probably something like that. But let's look at the more information first here. Okay. They say f prime of 2 does not exist. So the derivative at x equals 2 doesn't exist. How can this happen? How can you have a derivative like not exist?
What's it called? Is it cusp? Is that the word?
Cusp, yeah,
No.
or a sharp point. Sharp point is usually.
Yeah.
So if you have, for instance, a graph that looks like this, okay, the derivative goes from positive to negative, and it switches very quickly here, which means it's discontinuous. So that's why the derivative doesn't. So we know at 2 the derivative does not exist, okay, which means... you're right, Gabriel.
Is it 5?
Is it 5? Is what 5?
The answer.
No, the answer is not 5. We're graphing things. There are no numbers for the answer. Okay. So that means at 2 here, there's got to be some sort of like sharp point. And what we know is that when it's less than 2, the derivative has to be negative. My two choices were like it could be like this, or it could be like this. But because I know less than 2, it has to be pointing down. That means it probably needs to be something like. Okay. All right.
Yeah.
And then they tell me f prime of 4 is equal to 0. Okay, what does that mean?
Is a turning point at x equals 4?
Yeah, it has to be a flat point. So it probably has to do something like this. And then we know, right? If it's greater than 4, it has to keep going down, right? From here. This is why this is kind of like a puzzle. And then let's see. If x is greater than 0. Oh, no. Okay. And then they say the derivative is positive, if x is between 2 and 4. Well, that's true here, right? See how this is positive? Always going up. That's good. And then f double prime of 2 does not exist. Well, yes. If the first derivative doesn't exist here, the second derivative doesn't exist either. So, yeah, this ends up being your final graph.
It's a weird graph, isn't it?
It is. It is a very weird graph. Yeah, no, this is a weird... And a lot of times, actually, what they do is they'll give, like, a weird, like, piecewise function or something, and then they'll tell you to graph it. But, yeah, this is an example of something that... It's like a puzzle. You got to go through and be like, ooh, it could be this or this, but let me look at the next thing. Like, oh, the derivative has to be positive. Okay. Yeah.
That's pretty cool.
Yeah, right? Yeah, it's neat. Wow, they
Yeah,
have
no, 'cause
something.
I haven't done like interval or
Yeah, that's
I've
so
barely done
interesting.
double derivatives to be honest.
Yeah, the curvature ones are
I
weird,
haven't
right?
done cusps or anything.
Cusps and
Yeah. That's weird.
I'm gonna say domain range. One with the asymptote. I swear, sometimes when I help like kids out like outside, I should just take their homework. Oh, this is a good question. Okay. Okay. Let's do your tree question. Ah.
See, I feel like I could be being really stupid with this.
All right. Let's convert this into. I'm gonna call these things X, right? I'm gonna call these things Y. I'm gonna call these things. All right.
Mm-hmm.
So 2x plus y plus 3z is 10. Okay, wait, what the fuck is this? How many trees is this? This is 2, right? Wait.
Yeah.
I think. Is this 4 then? Is this 4 trees? I think.
To be
Okay, no,
honest,
wait.
I just said.
Wait,
Yeah,
I
I
think
just said it was X.
it's just x. This is 2x. Dude, I look at this, I'm like, wait, how many trees is this actually? Uh-oh. This is 2x plus y plus. Okay, I need to stop with. No, we're just going to call that z.
Did that as well.
Plus z 16. And then this is x.
It's fairly
Plus.
obvious.
But then this is interesting, bro, because this is like technically 2/3 of a z, right?
Yeah, this is like what's that? 5/3z.
Yeah.
I
But I think they just messed. You see how this looks like a image thing got like. I think they just didn't copy the image correctly. We can try both eventually, but I think I'm gonna call this one.
I'll put it as 5/3.
You did put it as 5/3?
Yeah.
Okay. All right. Well, let's see. Let's see if it is. And then plus what is this 3y is equal to and then this is what we're solving for.
Yeah.
Ah. Okay. That's interesting. Well, right off the bat, right? You can determine what x is here, right?
Yeah.
In these two.
I
Alright.
got 6.
Yeah, good. So if I take this equation, I subtract this one, I get x is equal to 6.
Yeah.
Cool. So now I know this is 6.
And then that's as far as I got because I said, hey, hang on a minute. It doesn't matter what Z and Y are. You can't solve for Z and Y, really.
You can't. Yeah, you literally can't because this is what we call it. Yeah, these variables can't be separated. Same. Okay.
But I feel that's a bit like advanced for a Facebook question.
Yeah, what?
I don't think there's an answer.
I don't think there's an answer.
And it won't matter if it's like 2Z, like you said, anyway. Because even then.
Well, okay, here's the only way this would make sense. If this, for instance, were 3Z, right?
Hmm.
If there are 3 of these, then I'm okay, right? I think I'm okay, right? Because if x equals 6, right, that tells me that y plus z is equal to 4, right?
Mhm.
And then I know this would just be 3 times 4. That's what I think has to happen. Yeah, I think they screwed up here. I think they need a third tree. Yeah, because you're right. Otherwise, it's not solvable, right?
Yeah.
Yeah. Pretty weird one. Wow, that's kind of cool. Nice.
Wait, so hang on. If we said that Z was those 3 trees
Yes.
at the top, then how are you getting 3 trees at the bottom? Surely it's like 2Z. If you think
I know it's
about them as
2.
one.
I think they messed up. I think they meant to draw 3 of them.
Hmm.
That's the only way this makes sense. Otherwise you literally can't solve it. I don't think you can.
What a stupid question.
Well, that's Facebook for you. Right? They just put on Facebook.
Nice.
There's a lot of
Nice.
dumb things. Didn't Jamarcus say he was gonna have some really hard questions for us today? Marcus, where are those questions, dude?
Yeah. I think he did them though.
Hey, I love when he hits me up. He's like, "Oh, I have these questions," and then yeah, we're like dreading them. We're like, "Oh man, these are gonna be very hard." But, oh no, they're not. Let's see.
You know, he asked me a question the other day, and it like
Yeah?
looked really hard. I didn't even know what a lemming was, to be honest. It was about a lemming.
A lemming? Like the
Yeah.
character of the Lemmings?
No, it's some like weird bird thing.
Yeah, no, lemmings are
Here, I'll put it in help screenshots.
yeah, put it in the help screenshot. Oh, I guess they're rodents. I know them
Oh,
from
rodent.
a rodent. I know it from the video game Lemmings.
Oh, wow.
This is the very old game. Yeah. So I guess there's something about lemmings that they like blindly follow orders, so they'll jump off of cliffs or something.
That's weird.
Yeah, here you go. Unless assigned a task, each lemming will walk in one direction, ignoring any other lemming in its way, falling off of edges and turning around if they hit an obstacle. So, yes. I wonder where this comes from, though. Like, is this a real thing? Do lemmings actually like jump off of shit? Like what? Lemmings jump. Okay, jumping off a cliff. Yeah, dude, lemmings really commit mass suicide. Excuse. Okay. Okay, so in the 17th century, perplexed by the habit of Norway lemmings to suddenly appear in large numbers, came to the conclusion that the animals were being spontaneously generated in the sky and then falling to the earth like rain. Oh, man. So, okay, lemmings do not commit suicide.
That's boring.
Okay, so apparently lemmings have a huge population booms every 3 or 4 years. When the concentration of lemmings becomes too high, a group will set out in search of a new home, and as they do it, a couple will drown. Yeah, because I've heard that this is like an insult before. Have you heard this? Like someone calling you a lemming?
No.
Oh.
No one's ever called me that.
I don't know. It seems like a British type of something. I don't know. But yeah, there's this. A lemming is someone who just follows orders blindly. Like if someone told you to jump off a bridge and you just did it, you'd be a lemming.
Okay. Oh, we say that's a sheep here. Like you're a sheep.
Wait, what is this? Okay. For the night, yeah, you're a sheep. Yeah, no, we use that one too. For the 1958 Disney nature film Wild Wilderness, filmmakers engaged for dramatic footage, and they staged a lemming death plunge, pushing dozens of lemmings off a cliff while the cameras were rolling. And this apparently convinced several generations of moviegoers to believe that the rodents do possess a bizarre instinct to destroy themselves. Wow. Disney at work. You know, speaking of Disney, right? Teacup's at Disneyland right now. Like, apparently they pushed a bunch of rodents off a cliff in a movie. What?
No.
Now I want to see this.
Oh, no.
He's like, oh, no. I doubt it's actually up. Wild Wilderness.
Oh, no.
It's all fake. Oh, it was a fake nature documentary, apparently. The lemmings and the Wild Wilderness, the lemmings and the Arctic Circle of Life. Apparently what this is. Okay, I'll leave that for you guys to watch. I should next. Apparently Disney did that. They found footage. They found footage of lemmings jumping off a cliff, but in reality they just pushed them off. Like, god damn it.
Great.
Yeah, great. All right, cool.
We'll have to let Teacup know.
Oh, Ethan's here too. Okay, cool. Oh, we can do Ethan. I want to see what this thing with the lemon. Marcus posted this one.
Yeah, it's See, once you read it, or try to do it, the questions like
Yeah, Lemming
really,
sits on the
really,
corner of a
really
square.
unnecessary.
Side 10 meters. The lemming runs 6.2 meters along the diagonal towards the upper corner. Okay, so it goes this way, right?
Hmm.
0.2. It stops, make a 90-degree right turn, and runs 2 more meters.
Yeah.
What is the average distance of these 4 distances in meters? Is it as annoying as I just need to figure out what this coordinate is and then do the distance formula for everything?
I didn't do it like that. No.
Oh, how did you do it? I mean, I would just get this coordinate just from vectors, and then I could do the. What's up, Fresh is best?
I'll put my solution in help screenshots.
Oh, okay.
But, like,
Let's see. Let's see. All right.
half the question isn't
You
even
have such
necessary.
nice handwriting, Noise. Like what? Nicest fucking handwriting I've seen. Average length is. Okay. Length is equal to. Oh wait, it's the distance. Oh, each side of the square. Oh, sorry, it's not the corners. I thought it was the distance with the corners. I see. Okay, very cool. This. Okay. Are all 10. Wow, this is elegant, Noise. I do like this. Yeah. Right. Okay.
I
Right.
thought it was
So
a bit of a stupid question, to be
no,
honest.
it's great. No, this is very elegant. Honestly, I would have gotten the coordinate and then I would have done all the. But this is way better. Yeah. Average length is this length plus this length plus this length plus this length all divided by 4. But yes, you know this plus this plus is 10. This plus this is 10. Which is 5. Wow. That's super cool. See, Noise, you have a very particularly smart brain, able to like see patterns like that's cool. Like this is the difference between my brain and your brain is that I would just brute
No,
force.
I spent like 15 minutes looking at it.
Oh really? Oh, I would just brute force this. Like I just see this and the RAM that I am, I'm like fuck it. Like let's just get a coordinate. I'll do the distance for it. But this is way more like elegant. And I think this is what you really need in order to do, for instance, like theoretical physics or any sort of, high-level math graduate stuff is you have to have an eye for the elegance within math stuff like this. I'm an experimentalist physicist. So whenever I see a problem, I just use the tools that I know I have, and I know I can figure it out somehow.
Yeah.
It's a different way of thinking. This is why I was always very terrible at theory stuff because whenever I would try to do theory work, I had to do some theory work for my PhD. I absolutely hated it because I don't really see the beauty and the elegance and stuff. I just start raw number crunching. I'm like, screw it. Like, get a computer to numerically approximate it. But what ends up happening is then you have like 40 hideous terms. I showed you my thesis, right, with all those terms, right?
Yeah, no, I think you sent me it.
Yeah, right? It's terrible. Whereas I feel like a theoretical physicist would be able to see like, oh, these things are insignificant, and I don't know, this forms some cool Cauchy whatever identity, so we can reduce it to this, and then this answer is a lot beautiful. So it's cool. Maybe, I'll probably get better at noticing things like this. The more you see things, the more you recognize them later, but there is definitely an innate talent to just. Okay, cool. Ethan, what's up? You want to do your question? We're gonna do some physics here. Physics. Yeah, that's cool. I wonder if they have this in. Let's see if they have this in the Brilliant series. Like, if I were to give Ethan a physics assignment, what would I do? Probably go to. It's just physics. I wouldn't give him physics. Okay, I'd probably give him this, right? Classical mechanics. Oh, good. Look at this. They have kinematics. This is cool. Here we go. This is what I'd give him. I'd give him the Newton's laws. Oh, and I can share this to a classroom.
You can give me the Newton's laws and stuff.
Yeah, no, I'm gonna give you access to all this stuff because I think you would use this very well. And look, it's got these cool animations and stuff. And they have questions and they have explanations and stuff. So, I think this could be very useful for you. I'm glad they're giving me access to it. That's pretty.
I'm glad you're actually kind of thinking about me and doing work.
No, exactly. Yeah, no, I was thinking about you. Yeah, like off the top of my head, they were like, "Oh, do you have any students that would use this?" And I'm like, "Yes, Ethan and Jamarcus. Ethan Jamarcus would love this. I know Noise would love it. So yeah."
Well, I do love this for a fact.
Well, it's nice because like it's free. Usually it's $160 a year to get access to all their courses, but they're giving them. Yeah, cool. Good job, brilliant. Thank you. All right, let's see this one. This is Newton's laws, because I see forces and whatnot. And then they want to know acceleration. Kind of cool. All right, so first thing, Ethan, before we even start this question, I always like to see, what type of formulas we're probably going to use, right? So here I see Good. Yes, exactly. All right. I see a mass, I see some forces, and I'm asked for the acceleration. So what I'm going to use is F is equal to ma. But more specifically, what this is that F net is equal to m times a, and then this holds in each direction. Okay. We say.
How do they hold in each direction?
What's up?
How do they hold in each direction?
Good. So if I look at, for instance, here, let's do a different question. Let's say I have a box, okay, and I apply a force, right? Let's say I apply a force in this direction. Say this pushing force. This is 50 newtons, okay, and then let's say this mass is equal to 10 kilograms, okay. Now, if I want to look at, okay, and then there are other forces on this box. Okay, what force is always acting on something if it's on Earth?
Gravity, right?
Good. Yes. So we would say there's also going to be what's called a force of gravity. Do you remember what the value for the force of gravity is?
9.81.
So it's the mass times 9.8. The other way they write this, they say this is equal to mg.
10.
No. I say 9.8, but Ethan insists on 9.81, which is okay. I mean, 9.81.
Of course, I told him it was 9.81.
Is that what happened? You started him on this? Did you start him on the 9.81?
Yeah. Sorry, that's my fault.
Yeah, I usually just take the first thing I see in my mind.
Okay, cool. All right. Good to know. So we got to make sure we teach you the right things first. Okay. So, all right.
It's still not right at the end, though.
Yeah. So you are right in the end. Okay. So let's remember what the equation is that we knew, right? We know that F, right, or F net, or here, let me use a different color. Use brown. Okay. We know that F net, right, is equal to the mass times the acceleration. Okay. Ethan?
Okay, yeah, sorry. Yeah. I sometimes have push to talk, so I'm still a little unfamiliar.
It's okay. You're getting it. Okay. So I'm pushing this block, right? I'm pushing it to the right. All right. Which way do we think this thing is going to accelerate? I push on the block to the right.
Which way do we think this thing is
Going to accelerate or move, basically.
It's gonna move to the right, right?
Good. Yes. Right. And we're gonna assume that it starts at rest, right? It starts not moving at all, and then we start moving it. So that means it accelerated because the velocity changed. Okay. Because it went from being still to moving. Okay. All right. So specifically here, Ethan, right? There is an acceleration that points to the right. Okay. But the acceleration does not point up or down, right? Because this thing is staying on the ground. Okay?
Sorry, could you repeat that? I literally had a bad connection just now.
Okay. Okay, so this object, right, Ethan, it moves to the right, okay? So, because it's going from rest to moving, the velocity is changing. But the velocity is changing only in the left-right direction. Okay, we call this the x direction.
Yes, it's changing from.
Good, good, okay. So when I use F equals ma, right, F net equals ma, how can I solve for the acceleration of this block? What numbers am I going to use?
I think 10 and the FG, right?
Not the FG. Okay, so again, we are going to use the 10. The 10 is the mass. I agree with that, right? So I'm going to say, okay, 10 is the mass, right? We're trying to solve for the acceleration. And then the force, the net force, what is the net force on this object?
50, right?
Good. Now, it's only 50, though, Ethan, in the x direction, okay? Do you see how technically there are forces in the up-down direction?
Yeah.
Okay. So if we wanted to solve for this, I'm going to call this AX, just to show you something, right? I could solve here, right, and get that AX is equal to 5. This is meters per second squared, okay? Does that make sense, Ethan, how the math worked out here?
I just saw you.
Right.
Wait, hold on. Aren't you multiplying them? Aren't you multiplying them?
Yeah, I'm doing 10 times A, so I'm dividing by 10, right? And then this
Alright.
gets me 5.
All right.
Right? Okay.
Yes.
The important thing here, Ethan, right? This acceleration only points in the x direction, okay? Because what do we know about the object in the up-down direction? Is it moving in the up-down direction?
No, it's just staying still. It can only
Staying
move
still.
in the X.
Okay, good. So this was me doing F net in what we say is like the x direction. Let's look at what F net would be in the y direction, okay? So in the y direction, that means the up-down, okay?
Okay.
All right, so let's use F equals ma to solve for this, okay?
So I think what we.
Yeah.
That's the goal.
Yeah.
I think we got the FG and the 10 this time.
Good, we do, right? So FG, so that's the 10 in this, right? And what direction does this point? What direction does gravity point?
Downwards.
Good, so I'm going to say negative. Anytime something's going downwards, I'm going to make that a negative force. So I'm going to say negative 10 times 9.8, right? Is equal, right, to the mass times acceleration, m. And then, but what do we know the acceleration is?
I really don't know.
So is this object moving through the ground? Is it falling?
No, it's on the ground already.
It's stuck, right? It's not moving any further, right? What does that mean the acceleration is?
0, right?
0, good. So if
Also,
this
don't
is
we know
0.
M?
Sorry?
Don't we know M already? Like,
do.
It's in that.
Okay, let's do it. We do know. Yeah, right. Okay, Ethan?
And that's FG. There's FG now.
This is mg, right? Yeah, this is all FG. But in order for this to be true, Ethan, you see how this is 0? 0 can't equal negative 98.
True, yeah.
So what this tells us, Ethan, is that there has to be another force that opposes this force of gravity that's trying to keep it down.
Okay.
What do you think that force could be?
Is it the 50?
Close. So the 50 only points in the left and right direction. We need another force, Ethan, that points straight up. Okay? We need a
And I'm
force
guessing
point.
that's
Yep.
0?
This is going to be what's called the normal force, Ethan. This is called the normal force. So, I know, the normal force kind of seems like a weird thing. But what it is for any object that is resting on, like, a surface and isn't going through the surface, right? You know, this block isn't falling down to China. That would be bad. There must be a normal force pushing against it that keeps it with 0 acceleration, the up-down direction. So
Okay.
Ethan, the force of gravity is trying to pull the block down, okay? But I know that the block doesn't fall into the ground, so there needs to be another force that keeps it up. That makes sense?
Not really.
Not really. Okay, okay. All right, let's think about this. So you're standing on the ground, right?
Not really. I'm literally on the bed right now.
Okay, you're on a bed. That's cool. So you have the force of gravity, right? Trying to push you down into the bed, right?
Yes.
Okay. But there has to be some sort of force that prevents you from, like, falling through the bed, right?
Oh, you mean like the gravity could go heavier and push me down through the ground?
Yeah, right? If there wasn't another force that kept you up, right?
That is kind of weird. So you mean to tell me that gravity is completely big or something? Because apparently it can be so heavy enough to push me down to the ground.
Yeah. Unless there's a force that keeps you up. And the force that keeps you up is what's called the normal force.
Okay, so this is what keeps all of us balanced from going
Yes.
down and down.
Exactly. Okay.
All right.
So what that tells us is that, and this comes from the F equals MA thing, right? You see how this is F net equals M times A? F net is the same thing as saying the sum of all the forces. And in the up-down direction, right, I know my acceleration has to be 0 because it's not moving up-down, which means that if the force of gravity is trying to pull me down, I need another force to push me up so that these cancel and become 0.
Yeah. Okay.
And that other force, that ends up being called the normal force. Okay.
All right. So it's gonna be like 0 there, right?
Well, I want the whole thing to be 0, right? So this is going to be, right, minus 98. So what does normal force need to be so this plus negative 98 is equal to?
Positive 98?
Good. Exactly, Ethan. Yes. This is 98 Newton. Good. Awesome. You just figured out what normal force is. Very cool.
Please, I really still don't understand much about
I know. You understand a little bit of it. Here, we'll get into it more. But the key thing I wanted to show you here, Ethan, is that acceleration and forces are specific to the direction. Okay? So if I'm looking at the movement of something in the left-right direction, right? If I'm looking at the acceleration in the left-right direction, I only use forces left and right. And if I'm looking at the acceleration of something up and down, I only look at the forces that are pointing up and down. Okay? Because you see how this thing has acceleration this way, but it doesn't have any acceleration this way?
Okay.
All right. Okay, so let's come back to this problem. We kind of went on a little bit of a tangent with normal force and gravity. It's important for you to see that. Don't worry too much about completely understanding it now. We'll learn more about it later. This is an example in science where we introduce a concept to you to kind of, get the brain warm to the concept, and then you'll see it again. But because you've kind of seen it a little bit before, it won't be as difficult to understand.
Okay.
All right. Okay. So we have a mass here, right? Which is being pulled on by some forces here. Okay. They tell me the first force here, right, is 850 newtons. And then they tell me the second force here, right, is 815 newtons. And then they give me some different angles.
These are 0, 1, and 0, 2.
So, theta. They call it theta.
Okay, wait. Why do these zeros have like a little line in them?
So this right here, Ethan, this is called theta.
Right, I remember mixing it up with a 0.
This means
All right.
Okay, cool.
Wait, apparently that's cool.
Yeah.
Apparently there might be an ugly answer to this.
Yeah, we'll see if it's ugly. It's okay. It's not gonna be too bad. All right, so this block right here, right? This block is experiencing forces that are acting in weird directions, okay? Do you see how this one's acting like diagonally and this one's also acting diagonally?
Yes.
Okay. Do you remember when we had, for instance, like the ball being like kicked at an angle? What was the first thing we did?
We have to label the sides of something.
Good.
Find the angle.
We got to break it up into components. For like Vy and Vx.
Yes.
We're going to do the same thing here, Ethan. I need to break up these forces into what their Y components are, okay? And what their X components are.
So yeah, I think you could just. These are like two triangles together, you know.
Good. Okay, so
I mean, you gotta break up the components first.
so let's
So you gotta. Why don't we start with start with the top one?
yeah, we can start with the top one. Let's call this like F1Y. Let's call this one like
Okay,
F2Y, right?
What's with the F1 and F2?
So F1 means, see how this is force number 1?
Yes. Yes.
And this thing is force number 2?
Yes. You see that?
This is a way to designate that F1Y is the Y component of the first force, whereas F2Y is the Y component of the second force.
All right.
Let's try to get some numbers for these, right? How do I figure out what F1Y is?
Well, I already know what is the hypotenuse, the adjacent, and the opposite.
Yep, trig functions.
So we already know that we gotta use either sine or cosine.
Mm-hmm.
So I want to use cosine first.
Which one do you want to use cosine for?
Isn't it for for the F1Y one?
We want to use let's try to find it for F1Y.
So if it's like the cosine of theta is equal to the adjacent over the hypotenuse.
Okay. Which side of this triangle is the adjacent?
It's like that little green line there.
Yeah. Is that the Y component?
No, that's the X component.
Good. Okay. So what would I do to find the
Are
Y
you-
component?
You have to find you have to use sine then?
Good. Yes. Yes.
When do you know what to use? Like if you use sine or cosine first?
You just have to look at the triangle, honestly. But most of the time, and double check this, but most of the time Y uses sine, and cosine uses and cosine is for the X direction. That's usually
Alright. So we gotta use sine.
Good. Okay.
So it's like the sine of theta
say
is
the sine of 35 degrees.
equal to the opposite over the adjacent. Did you
so-
already know it's like
No, not
F1Y.
opposite over the hypotenuse.
Yes, I just forgot that.
Good.
So it's the opposite over the hypotenuse, which is F1Y, and the hypotenuse is equal to 5 newtons.
850. Yeah, good. Very good.
Okay, I completely mix these up every time, huh?
What do we do next?
So I think you want the F1Y by itself, so you gotta multiply 850 on both sides.
Exactly. Good. rid of this.
Or you could. So then you gotta figure out what's 8% of 5 degrees.
Yeah, let's do it. Calculator out.
Also, I also feel like my brain's a bit slow today.
Okay. It's Wednesday. My brain's slow too. Thank you, Noise. Noise is done all the calculation. I'll do on the calculator. This is 487.5. Okay.
87.5.
487. So say F1y equal to 407.5. Okay.
Alright.
All right. So we figured out what this one is. Let's stick to only looking at things in the y direction for now. How do I figure out the next y component of another? What's the y component of the other force that I'm?
Are you looking for F2y?
Good. Yes, exactly. What do we do there?
Alright, so since we use sine, we gotta use the opposite, which is cosine.
Oh no. So we're not doing the opposite side. We're doing a different force. It's still in the y direction. So look at this triangle, Ethan, for instance, right?
Yes.
You see how this is still the opposite? This is the hypotenuse.
Yes.
Jason.
I see that.
So we're still going to use sine to figure out f2y.
Okay.
If we go to the x direction, you're right, Ethan. That's when we start using cosine.
So it's like the sine of theta is the opposite of the hypotenuse, like you said.
Hmm?
So we already know that the opposite is F2y.
Good.
And the hypotenuse is 815 newtons.
Very good. Very good. Done.
We do the same thing like last time, where we multiply 815
Both sides, right?
and yes, and we just gotta figure out what's the 815 sine of 25 degrees.
Good. Yes, exactly. Nice. Let's do that. Right. So this is going to be this is going to be 815, right? Sine of 25 degrees, which
It's not showing on the calculator.
what?
It's not showing on the calculator.
Here I have 1 sec. 815 sine of 25 degrees. Do you see the calculator? Is the calculator not showing?
It is now showing this.
Yo, what's up, Rocky Man? How's your Wednesday going, dude? Okay, do you see how that's 344.4?
Yes, I see that.
Very good. Okay. Now I'm going to replace this. Say this is 344.4 newtons. Okay?
Does the same go for F1y?
F1y was 487.5.
Yeah, but then is newtons the variable?
Oh, yes. You're so right. Sorry.
Alright.
Now, here's the important thing here, Ethan. Okay? We
They are
found all the forces in the y direction. So now we can use F equals ma to figure out the acceleration in the y. Okay?
Alright.
So we know, right, that F net in the y direction equal to the mass times the acceleration in the y direction.
Alright.
Okay. So F net in the y direction means add up all the forces in the x direction, right? What are my forces in the x direction? Which ones do I have?
The two that we calculated are in the y direction.
Good, very good. Yeah, so what are the forces in the y direction? That's what F net y. That's what we're trying to look for.
But before you said what are the forces in the x direction?
Oh, sorry.
Before
Yeah,
you said-
I mean the y direction.
Alright, so it's both of these. I guess you gotta add them up.
Good, you do add them up, right? So yeah, I am going to do the 487.5, but there's something tricky about adding F2. And it has to do with the direction of F2.
Oh, it's up and down, so you gotta subtract.
Good. So we're going to put a minus sign on this one. Right? Really, I'm saying like plus negative, right? This is like a negative force, but that just turns into a minus sign.
Yeah.
Okay.
Yeah, or no.
Good. All right. And then I can put the mass, right? The mass we know, what was that? 3680? And then we have and then we're going to solve, right, for what the acceleration is. How do we solve? And this is the acceleration in the y direction. How do I solve for that acceleration?
So I think you've got to figure out what's the 487.5 minus 344.
Good. Let's do it. All right. That gets us 143.1. Noise says you only did half the question. Oopsies. Oopsies. 3680. Okay, AY. All right. What do I do next to solve for AY?
I don't think you want 3,680 AY. You just want AY, so you gotta divide. Wait. Yeah, divide.
You're right. Yeah.
2,680 for both sides.
That's good. Let's do it. 3680, right? Good. Okay. That goes away. And we're left with AY is equal to 0.039.
Oh, I got that.
Oh, you did get that. Yeah, okay. Wait. You got 0.39.
Oh.
Did I do something wrong?
0.39.
I got
Oh
0.039.
shit, I might have typed it on my calculator.
Yes.
Wow, nice.
Okay. 0.039. Okay, cool. Do we see that?
Yes.
Okay, so I know AY is equal to 0.039, and then we're going to say this is meters per second squared. Good. All right, so we've got the acceleration in the y direction. However, this object will also have an acceleration in the x direction. Do you see how there are forces pulling it in the x direction?
Yes. So
Right.
I think now is the time we use the cosine, right?
Very good. Yes. Now what I'm going to solve for is, for instance, I need to figure out what F1x is. So that's the component of F1 that points in the x direction.
Okay.
All right, how are we going to figure that out?
So it's like cosine of beta is equal to the adjacent over the hypotenuse, right?
Good, good.
So it's like the cosine of 35 degrees, right?
Hmm.
Is equal to 850 Newton.
Very good.
Wait, it's the adjacent, right? It's the adjacent. So that's not. Adjacent,
Oh, sorry,
right?
you're right. So the adjacent, is F1x, right?
Yes, F1x. Divided by 850. And so you got to multiply 850 by both sides.
Good.
And so
Okay.
you got to use a calculator for this. And I can imagine it's smaller since sine and cosine are opposite.
Let's see. Actually bigger, Ethan. 696.3.
Wow, okay.
I can show you why that is. 190. Reason being, Ethan, do you see how this thing points at a 35-degree angle?
Yes.
That means more of the force is going left-right than is going up-down. Right? Let's consider, let's say I pulled it at like a 2-degree angle, like a really narrow angle here, right? You see how most of the force is pointing this way, but only a very small amount of it pulls it up?
Yeah.
That's why, because this angle is less than 45 degrees, that's why the x component is going to be greater than the y.
Alright. And then we gotta figure out what's F2x.
Yes, good. Let's figure out F2x. Okay.
So it's like the cosine of theta is equal to the distance over the hypotenuse yet again. But this one is cosine of 25 degrees over f2x divided by 15 newtons.
Very good.
Multiply a15 on both sides and figure out what's a15 cosine 25.
Very good. You're getting the hang of it. See how this is getting easier?
It's only because it's trigonometry. I'm good with
Yeah.
that since I
Good.
did learn it.
Well, it's good that you keep learning it, because what this means is, Ethan, when you go back to school, because you use this all summer, you're not going to forget it, which means you're going to do a lot better in your classes. You're going to be like, oh, I've been doing this all summer. I remember it. Your other friends are probably going to forget because they've never done it.
Most of them are smart, okay? Smarter than me.
No, you're pretty smart. Pretty smart, Ethan.
I just
I'd
want to be
say
the smartest person.
what's more important than you being smart, Ethan, is that you're determined. Like, you have perseverance and, like, drive. That's the most important thing. Like, being intelligent helps, but having the motivation to learn things and to do it on your own, that's the most important.
All right.
Don't worry about other people. All right. How do we figure? Okay, so now we have the sum of we have different forces here. What is this going to let us figure out now?
What it is in the x direction.
Good. What the acceleration is in the x direction, right? So I know that F net in the x direction, well, the mass times the acceleration in the x.
All right. So we already know that about f1x and f2x.
Good.
So since they're going on the same side,
Yeah.
I'm guessing that they're not, since they're going to the left.
Yeah. So they're both going the same side. They're both going left. So what are we going to do with the numbers?
We're gonna put them negative, like I just
Good.
said.
Very good. Yeah. Very good. So negative 696.3, and then technically it's plus negative 738.6, but we can just write that as a minus.
Why do you even gotta show the plus sign? I already know it's gonna be minus.
Yeah, just because some students get confused with that. They're like, oh, wait, why are you subtracting? And I'm like, oh, because technically we're adding a negative.
Okay. So and then we want to know ax. We already know what the mass is, 3,680, right?
Good.
And so we gotta do the same thing like last time. Figure out what's negative 696.3 minus 738.6.
Good. So it's negative 1434.9.
Wow, that's
Okay.
such a high number.
It is. It's a very big number.
And so you don't want 3,680 AX, you just want
Good.
AX. So
Good.
same thing like before, 3,680 on both sides divided by it.
Good.
And that leaves us with our other answer.
Which is negative 0.39. Okay. AX is negative 0.9. Cool.
Are you correctly? I think. Did you make like a number in there?
Oh, I did it
Is
right.
it? Isn't it? It's like 0.38.
Oh, 0.389. I'm rounding the 8 to a 9.
Oh, so these two are technically the same.
No, because this is 0.039. Oh, wait. Sorry, you're saying this number and the number on the calculator?
Yeah.
Yeah, they're basically the same.
Okay. But all right. So one of them is positive and the other is negative. All right.
But also, do you see how this is an additional see how there's another 0 before the decimal?
Yeah.
No decimal here. That's the difference.
All right.
Okay, so now we have the acceleration in the x direction and the acceleration in the y direction. But what they really want to know is what the magnitude of the total acceleration. Okay?
So what does that mean, first of all?
Good. So let's this is where we got to review a little bit on like how vectors work, okay? So let's say I have an arrow that goes this way, but then also goes a little bit this way, okay? And then the total path is this, right?
This sort of makes a triangle.
does. Actually, here, let me make it a little simpler. Okay. Let's say we go to the right a bit, and then let's say we go up a bit. Okay. If I wanted to take the same path, right, I could just do the diagonal, all right? This right here is called what we say is like the resultant, but really this is like the magnitude. What it is the length of this thing.
Alright.
Okay. So let's draw something real quick here. Okay. So my here. Okay, Ethan. So my acceleration points in two different directions, right? I have some of it is pointing in the y direction, right? And some of it's pointing in the x direction. So I'm going to draw arrows for each one of those, okay? I'm going to draw an arrow for this one, and then I'm going to draw an arrow for this one, okay? Actually, here, let me make this. Okay. So in the x direction, right, the acceleration points to the left with 0.39, okay? So I'm going to draw an arrow like this. Okay?
That's so big there.
It is, okay. And then I know the acceleration also points a little bit up. Okay?
Okay.
So if I want to draw what the overall acceleration is, okay? This is an additional topic we can go into later, but what I need to do is I need to add these two things up to get what's called our resultant, which is going to be this. This is called like the resultant.
All right.
So do you remember last time, or sorry, not last time, do you remember at the beginning here how we had a force that pointed diagonally and we broke it up into the y component and the x component?
Yes.
Now I have an acceleration, okay, that is in the y component and the x component, but I want to put it back together into full acceleration. All right? And then when they ask for the magnitude, they're asking for how long is this like put together acceleration. Okay?
Okay.
I know it's a tricky concept. It's all right. You're going to get it. You're going to get it. Okay. So we have these are the components, right? I have the amount that the acceleration points up and down, and I have the amount that the acceleration points left, right. But I want to add those two together and figure out what the total acceleration is. All right?
All right.
How do you think I can get this? What shape does this look like to you?
Isn't that a little simple, like a triangular shape?
Good. It's a right triangle, right?
Okay.
Okay. So how do I what is this part here? What is this in the right triangle? What do we call that?
Oh, okay. I think an isosceles.
Close. Remember, if this is a side and this is a side, what's special about this side? Starts with an H.
The height?
The height. H-Y-P.
Oh, the hypotenuse?
Yes, this is the hypotenuse.
Then wait, what's so special about the other two?
These are just the sides, right? We could think of this as the adjacent and as this as the opposite, right?
Okay.
I want to find the length of this hypotenuse. That's what the magnitude of the acceleration is. It's taking the components and putting it back together as a triangle and figuring out what the length of the hypotenuse is. Right?
Okay.
How do I figure out the length of this hypotenuse? Right triangle. There's a theorem that you're going to use.
The Pythagorean theorem.
Yes, the Pythagorean theorem, right? How are we going to use that?
Okay, so
I can't spell hypotenuse.
it's like, sorry, not to go.
Yeah.
I'm kind of getting a little tired talking, but how
That's
the
good.
how the theorem? It's like a squared plus b squared is equal to c squared.
Good, good. It's this squared plus this squared is equal to this squared. Okay. So here,
Yes.
I'll label it for you because yeah, you've been a good sport. You've gotten through a lot. This is a long question, and so I'm very proud of you for getting this far. So here, I'll guide you through the rest of it. It's easy.
No,
So
I think I can. I think I can
Okay.
keep going.
okay, you got it. So it's this squared, right? Plus what?
Ay squared
Very good. And what does that all equal?
is equal. It's all equal to a squared.
Good, very good.
entire
Nice.
Yeah, we say like the total a squared. Very good.
And so we gotta plug in what we know. So we already know that ax is 0.39 squared.
Good. Do that. That gets us 0.1521. Okay. What
And
do we do
so
next?
we have, and we know that ay squared is equal to negative 0.39 squared.
Good. So that's gonna be 0.001521.
That should be negative, right?
No, because anything negative when we square it becomes positive.
All right. I can't believe Pythagoras' theorem has everything positive.
I know it does, because it's squaring things, right? Okay.
Yes.
So now we're gonna add these, right?
Yes, we're gonna add them.
Okay, so that gets me 0.153. Okay. What do I do next?
And then we don't want a squared, we just want a. So we gotta do the opposite of squaring, which is the like square root both sides.
Yes, dude. Square root both sides. Perfect, dude. Square root that number, okay? Now this gets us a final value, right? Of a
0.32.
392. Good. Meters per second. Very good job, Ethan.
Oh.
Wow.
I mean, I
That was a-
technically got the answer right.
Yeah, what did you do? This is what Noise did here. You want to see what Noise
I don't did half the question.
All right, I've been for a while. Let me just see this.
Wait, is
I
this
mean,
right? Is
technically I
this
got it
even
right.
right? Oh, you just got
Yeah.
the acceleration in the x direction. So here,
Yeah,
Ethan,
yeah.
he stopped and only got the acceleration in the x direction.
Okay.
That's right. That's
But it turns out that the acceleration in the x direction, right, which is 0.39, it rounds to be basically rounded out.
right. I see. I worked that out in my head.
No way, come on, seriously?
Yeah,
No
it's
way.
just it's a coincidence. It's a coincidence. But anyways,
Alright.
that's a very good question, Ethan. I appreciate that, dude. I hope you learned a lot from that, right?
Yeah, I learned some trigonometry.
Good, and some physics.
It's enough. I really just pushed my limit. I just really pushed myself to the limit. I could barely even talk now.
Here, I'm gonna give you an extra bonk one because that was good for you for doing that one, dude.
Well, thank you so much.
Yeah. You know, Ethan, I'm gonna give you a prize when you get to 200. I haven't announced it, but I'll give you a prize when you get to 200.
Okay.
You only need 51 more.
Wait, I thought it was on one. Oh, right, yeah, 149.
Oh, Sam says, what's the raffle ticket? Oh, yeah, sorry, that was for Monday stream. I should take that off. Don't buy the raffle ticket. Okay, cool.
Helping me with.
Pardon?
Thank you for everything you've helped me with. That's what
Of course, dude. Of course. No, I enjoy teaching, man, and you honestly, you help out a lot of other students with me teaching you this because they see the same types of questions.
But, you know, I kind of want to be like Noise where I can actually guide people through.
You'll get there, dude. Yeah.
honestly, like, if people were to ask like for help on systems of equations, I would be glad to help.
Exactly.
But if
Good.
it's but if it's a matrix, I don't even know what to do. I haven't even
Right.
learned that as yet.
Well, you haven't learned it yet, and that's okay. That's the whole part about being a teacher is you have to learn things well enough so that you can teach it to somebody else. But that requires you to learn it. Again, you know systems of equations because you've done it so many times. That means you can help people with it.
Yeah, but I feel like I've forgotten most of it.
All just comes down to
I
practice.
will very happily teach you matrices.
Dude, Noise is about to teach me matrices.
Matrices.
Noise, this linear algebra textbook, dude, is getting like tricky, man. Like, I may need to ask your help for like. I'm still on chapter 1, but like it's like 1.7 or
Alright.
something. It's like the theorems about transverses and stuff, and I don't know. Some of it, I'm like, wait, what?
Oh,
Because of this must be the inverse, or like proving that like something must be invertible. I don't know. Some of it seems to be like some like circular logic.
diagonal, triangular, and symmetrical matrices.
Yeah. Yeah, like upper diagonal, lower diagonal, or upper triangular, lower triangular. Yeah, there's a lot of them like that.
Okay. Okay.
So
Maybe I'll bring one of the questions to one of the office hours. We can go through it. Be a fun little thing.
I think
Yeah.
Ramtoon could probably explain it a bit better than
Yeah.
I can.
You know, the best way to learn something is to be able to teach it, man. That's what I always say. Cool. All right. Thank you, everyone, for coming to office hours. I had a lot of fun learning physics with you guys and all sorts of other things. Asymptotes. I'll make an announcement about the brilliant stuff. Yeah, because like Ethan, I definitely want to get you an account for that. Let me just make a post about it, and then I'll have you guys do it.
Also, could you like tell me how to sign up for an account?
I will. Yeah, no, I'm gonna make a big post with instructions and everything for you. It'll be really easy to use.
It also kind of reminds me of the Kudu stuff. Like I remember you posting a video about how to sign in.
Yes, I did. Yeah. I did the whole Kudu thing as well with you guys. Yeah, I remember I did do that. This is nicer than Kudu. They have a bigger budget. I think they have a seed round of like $13 million. So like they have some cash. They're doing okay. So, but it has some cool topics in it, and I'm excited to see how we can use it in our stream. So we'll see. Okay. Well, let's see. Today is Wednesday. I don't want to play Warzone anymore because Warzone is trash. I tried playing it yesterday, and the graphics are still bad, and even worse, the game crashed like within 15 minutes, and I was like, this is unplayable, dude. Like, screw this. So my idea was to replace Wednesday with a different game, which can be whatever. I think tentatively I said Apex. If anyone wants to play Apex, we can play Apex. Or I can. Is Tarkov up? Do you want to play Tarkov? Noise is Tarkov ready?
That might be tricky.
Is it
no.
ready?
I mean, we can play it technically, but it'll be very, very difficult for you.
Well, I mean, any game's gonna be difficult for me because I haven't played it before. But anyways, okay, I'm gonna have the people on the Twitch. We're gonna raid actual gaming. If you want to hang around and see us try to play some video games, I don't know, see my ass get handed to me in something, join us there. Otherwise, our next stream, we'll have Golden Hour tomorrow, same time, 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Come on by, ask whatever. We always have fun discussion. But yeah, if you want to keep hanging out with us, we'll be on actual gaming. And then what's up? What's up, Ethan? What's up, Ethan?
See, do you really think we can actually play Roblox soon? Because we haven't played it in such a long time.
Yes, we're gonna do it on Friday for sure. Yeah, sorry, I've been skipping it the last couple weekends because I've had to like teach it, but we will do it.
Also, do you remember the Doors game we used to play?
Yeah, Doors. Yeah, we can play.